In this video, we're going to talk about long-run behavior and the short-run behavior of the polynomials. So we learned that polynomials, the standard form of polynomials looks like this. Each one represents one term, second term, and goes, each one is one term. Each term we learn has a coefficient and has a degree. For example, p of x equal to 5 x to power of 8 plus 6 x to power 7 plus 9x to power 4 minus 5 x squared plus 5. So this polynomial has one term, two term, three term, four term, 5 terms. 5 is a coefficient of this, 6 is a coefficient of x to power of 7, 9 is coefficient of x to power of 4, and so on. The degree of this polynomial will be the highest degree, so the highest end will be the degree of polynomial, and the leading coefficient, and this a of n will be the leading coefficient of the highest degree. So the leading coefficient of this polynomial is 5. For the long run behavior, long run means you graph of x squared, you graph y equal to x squared, you will get something like this. You graph x to power 4, you will get something like that. And x to power 6, x to power of 8, we learned that all of them, they behave same. They have the same characteristic at positive infinity and negative infinity on the long run. So that means this, any polynomial, if you take a limit of that, so limit of p of x as x goes to positive infinity or negative infinity, it will be same as limit of a n x to power n minus 1 as x goes to plus minus infinity. So this polynomial, so we don't need to analyze all the other terms, only we get the first term. So back to this example. So if I ask you guys what is the limit of 5x to power 8 plus 6x to power 7 plus 9x squared minus 5x squared plus 5, as x goes to positive infinity, so we don't need to worry about this. We learned that this polynomial, they behave same as limit of 5x to power 8 as x goes to positive infinity. So if you answer this one, that means you answer that one, which is much easier. So x to power of 8 we learn is like a u, 5 is positive, so it's concave up. X goes to positive infinity, y gonna go to positive infinity. So the answer is positive infinity. Let's have, so that's the meaning of the long run. What you do, we just get the first term and we analyze that. The short run, for example, let's say we have a graph like this. So this is actually degree 4. At the long run, it will be same as u, but on the short run, that means we are interested to know what are the x-intercept. What is the y-intercept? So we need to talk about that. So this much, like from -10 to +10, for example, this will be all the short run behavior. So we need to talk about all the zeros, I mean x-intercept. Usually we talk about is going to be increasing, then it's decreasing, then again increasing, then increasing. So talking about increasing, decreasing, the local maximum, local minimum, and zeros will be short run behavior, which is a little more work than long run behavior. But most of the exercises, they ask you guys to find the zeros or x-intercept. Back to the polynomial, if you have p of x equal to a n x to power n plus a n minus 1 x to power n minus 1. This n, the highest degree, is important. If the highest degree, if n equal to 2, that means we are, at most, we have 2 solutions. If n equal to 3, we have at most 3 solutions, and n equal to 4, we have at most 4 solutions. So in this graph, we have 1 solution, 2 solutions, 3 solutions, 4 solutions. So this might be a degree 4, but definitely degree 3 is out, degree 2 is out. So this graph not going to be x squared and not going to be x cubed. It might be degree 4. So this n tells us how many solutions we have, and also tells us how many times the graph turns. If it's 4, if it turns, let me, it goes like this, that turns n minus 1 times. So in this, if it's 8 degrees 4, we have 3 turn. Let's have one example. They said find the zeros of the function y equal to 7, x plus 3, x minus 2, x plus 7. So this is great. So this is a polynomial, and they made it the factor form. They said find the 0, that means we're going to make this one equal to 0 and solve for x. Again, if it's in this form, which is great, it's a factor form already, that means we use 0 property. We're going to say x plus 3 equal to 0, or x minus 2 equal to 0, or x plus 7 equal to 0. X plus 3 equal to 0, x equal to -3, x equal to 2, x equal to -7. So if you find it, we have -3, 2, and 4, 5, 6, 7. -7, -3, and 2. So the graph will go through these 2 points. This is positive, so it will be, for example, might be something like this. Well, I will make it something like that. Should be like a chair, right? So from far away, if you see, so this is a cube. If you multiply all the x, at the first lead gonna be 7x cubed, the first term. So the long run behavior of this graph, it will be like a chair. But here, which is this one, all the zeros. So we find it. Let's have another example. Y equal to x cubed plus 7x squared plus 12x. So we have degree 3. That means we might have at most 3 solutions. At most. For sure we're not going to have 4, but we might have 1, 2, or 3. So in order to solve this, we need to factor it. Degree 3, I can take all the x out. We're going to have x squared plus 7x plus 12. Then this is same as x. Be x plus 4, x plus 3. If we make it equal to 0, we're going to have x equal to 0, x equal to negative 4, and x equal to negative 3. Great, we got it, we got 3. Let's have one more. Y equal to x to the power of 4 plus 6x squared plus 9. So this is degree 4. We should have at most 4 solutions, but we might have 1, 2, 3, or 4. So at most 4 solutions. I'm going to make it equal to 0. X to the power 4 plus 6x squared plus 9 equal to 0. And looks like this is 4, that's 2. We can apply the quadratic formula or same factoring for quadratic equation. Instead of x, I'm going to put x squared. 2 number you multiply is 9, add them is 6, should be plus 3, plus 3. So then we have x squared plus 3 equal to 0, or x squared plus 3 equal to 0. If they're exactly the same, so if you solve x squared plus 3 equal to 0, we get x squared equal to negative 3. So there is no solution here. We cannot make a square root because squared cannot be negative. So there is no real solution here, no real solution there. So we don't have 4, we don't have 3, we don't have 2, we don't have 1 solution. No solution. How does it look like? If you graph it, the graph might be something like that. So again, it's concave up, not gonna touch the x-axis. Why? Because we don't have any zeros. And the y-intercept is 9 here. Again, from far away, this will look like a U. Let's have one more example. I give you guys a graph, and I give you guys a graph and ask you guys what is the equation of the graph. Graph is looks like this. H of x. This is negative 2. This is negative 1. This is 1. This is 2. And this is negative 1. And we have 3. So we have a polynomial, the graph. So k of x is a polynomial. What degree is that? We have 1 solution, 2 solutions, 3 solutions, and here it touches. This means we have 2 solutions right there. They call it multiplicity. So x equal to negative 2 is one of the solution for this polynomial. X equal to negative 1 is another point. Here x equal to 1 is solution, and this will be x equal to 3. So we make this, we're going to say h of x equal to x plus 2. So x equal to negative 2, if you bring negative 2 there, you're going to have x plus 2. X minus 1 will be x plus 1. X equal to 1 will be x minus 1 squared because it touched the x-axis. Then we have x minus 3. So we have 1, 2, 3, 4, 5 solutions. And so we use all the x-intercept to come up with the equation, but definitely that's not enough. This is not enough. I mean, having only these points, we cannot have k of h of x, because another graph might have same type of x-intercept. So in order to find the unique h of x, we need to put a k here and solve for k. We have another point, which is 2 and negative 1. So 2 comma negative 1. X is 2 and y equal to negative 1. So I'm going to put negative 1 equal to k. Instead of x, I'm going to put 2. 2 plus 2, 2 plus 1, 2 minus 1 squared, and 2 minus 3. Negative 1 equal to k. 4, 3, 1, negative 1. If you multiply this, you get negative 12, and k will be 1 over 12. So if you plug 1 over 12 here for k, you will get exactly this curve.